The best way to get better at doing physics is to practice, practice, practice. This video is meant to help you practice. It is guided practice. We're going to do a problem together. I'll show you how I will approach this problem and solve it. And hopefully these videos and the subsequent videos that will follow will help you to develop a problem-solving strategy, a problem-solving algorithm that you can use so that even when you read a problem and you have no idea where to start or how to get from the beginning to the end, you're not stuck. You can get started. You have steps that you can take, and those steps will be the foundation on which your solution is built. Okay, so this particular problem deals with the kinematics of an object in free fall. A statue of Galileo is dropped from the top of a cliff. It hits the ground below after 3.75 seconds. How high is the cliff, and what is the velocity of the statue the moment before it hits the ground? First and foremost, you got to read the problem, and you have to make sure you understand what is being asked. Okay, it helps to recognize right away any physical quantities that are given to you. So in this example, time is given to us, and those quantities that you're asked to find. One thing we're asked to find is we're asked to find the height of the cliff, and we're asked something else. We're asked to find the velocity of the statue the moment before it hits the ground. There's two unknowns in this problem: the height of the cliff, the velocity of the statue. All right, read the problem, understand it. Next step, it helps to draw a picture. All right, and this can be as detailed as you want it to be. I'll draw a little cliff. All right, I'll label this top, bottom, and I'll draw a little statue of Galileo, and I will draw an arrow pointing in this direction indicating that he is falling from the top of the cliff to the bottom. And all right, so that's a pretty good picture. Before we go any farther though, remember we're dealing with vector quantities here, so let's define what we mean by positive and negative direction. So I'm going to call down positive. All right, so that's the direction of the motion. I'll call down positive, which would make any vectors pointing up negative. That's a pretty good complete picture. All right, next thing to do, let's look at the problem. Let's write down everything that we know. Well, we know that it takes Galileo 3.75 seconds to reach the bottom of the cliff. What else do we know? Well, we can make some definitions here. Let's call the top of the cliff y equals 0. Okay, which means that y naught is equal to 0 meters. Right? That's where Galileo is starting out, at the top of the cliff. What else do we know? It's an object in free fall. The acceleration of an object in free fall near the Earth's surface is 9.80 meters per second squared. Positive in this case because we call down the positive direction. What else do we know? Well, we also know that Galileo is starting out from rest. Sorry for this childish writing. I'll get better at this. But hopefully it's legible. All right, so that is a complete list of everything that we know. I don't think we're leaving anything out. So let's proceed. All right, the next thing, it's helpful to write down our unknowns. All right, and one of our unknowns is y, the height of the cliff. Okay, y after 3.75 seconds will be the height of the cliff. That's how far from y0 the statue has fallen in 3.75 seconds. The other unknown is v, the velocity of the statue after 3.75 seconds. Now, the object is to go from the knowns to the unknowns using a physics equation that we've learned. And in the context of this problem, the physics equations are the kinematic equations of motion. The kinematic equations of motion. And so I'm going to pause right now and give you a chance to pause the video and see if you can figure out the best kinematic equations of motion to use in this example to get from these knowns to these unknowns. Go ahead and pause. Did you figure it out? After I consider the kinematic equations of motion, the equation that makes most sense for finding y is the equation that looks like y equals y naught plus v naught t plus 1/2 a t squared. Why does this make the most sense? Because we know y naught, we know v naught, we know t, and we know a. The only variable in this equation we do not know is y, which is one of the things that we're after. Okay? So you could take everything that you know and plug it into this equation. Y naught, 0 meters, plus 0, v naught, 0 meters per second, 3.75 seconds is t, plus 1/2, 9.8 meters per second squared, times 3.75 seconds squared. Right. So if you multiply that all out, you get your answer for y. I don't have a calculator with me right now, but it's just plug and chug from this point. Actually, these two portions of the equation are 0 because you're multiplying by 0 there. All right, and v, after considering the kinematic equations of motion, the equation that makes most sense for finding v is the equation that looks like v equals v naught plus a times t. Plugging in what we know, v naught, 0 meters per second, plus 9.8 meters per second squared, times 3.75 seconds equals our answer. Again, I don't have my calculator with me, so I can't figure this out right now, but it's just plug and chug and you're at your answer. And that is it. There may be other ways to solve this problem. In fact, it's not unusual for there to be more than one way to solve these kinematic problems. There's no one right way. Oftentimes there's an easiest way, but there's no one right way. And in this particular example, the equations that I've used are the easiest way to get from the knowns to the unknowns. Okay, so with more practice, you will get better at this.